Hey everybody, in this video we're going to learn how to describe special angle pair relationships. So the first definition we're going to talk about is complementary angles. And complementary angles are two angles whose measures add up to 90 degrees. So any angle measurements, if the two measurements add up to 90 degrees, then they are considered complementary angles. For supplementary angles, these are two angles whose measures add up to 180 degrees. Okay, so linear pair is another special pair of angles that we can talk about, where it's a pair of adjacent and supplementary. We know that supplementary means that the angles have to add up to 180, but they have to also be adjacent. So what that looks like is that if we have adjacent angles and supplementary angles, that combination, let's say that on a straight angle, okay, so there's a straight angle or a straight line whose measure is 180 degrees, and if we have a ray drawing from any point on that straight line, we create two angles on that straight angle. So we have angle 1 and angle 2. And these two measurements on the straight angle, measurement of angle 1 plus the measurement of angle 2, would equal 180 degrees. So this specifically would be a linear pair, which is also supplementary and considered adjacent. Now adjacent angles, these are two angles that have a common side and a common vertex. And linear pair is a very specific version of an adjacent angle or adjacent angles. So if we were to draw that out, here is a bent angle, not like a straight angle that we started with. And if we have a ray coming from that common vertex, we have our angle 1 and angle 2, not necessarily congruent, but just identifying that these are two different angles. And there's our common vertex. So they have a common ray right here and a common vertex right here. So those would be considered adjacent angles. Alright, and then the last one is vertical angles, and these are a pair of opposite angles made by two intersecting lines. So if we're going to draw over this little adjacent, or created with doceri watermark, so bear with me here. So we have a straight angle, that's one straight line, and another straight line that intersects, and the two angles that are opposite of each other are considered vertical angles. So the measurement of angle 1 is actually equal to the measurement of angle 2. So these two angles are vertical angles and are the same measurement, and these two as well would be vertical angles with the same measurement. So in example 1, we have to identify angle pairs. In the figure, name a pair of complementary angles, supplementary angles, and a pair of adjacent angles. So for complementary angles, a little trick that I like to use to remember if it's going to be 180 degrees or 90. For complementary, I specifically would draw a 90 degrees with the C and the O, like that. So I know that's going to be 90 degrees. Okay, and I also noticed that we just have a typo here, so we're going to fix that really quick. This should be an E, not an I. So make sure you fix that so we spell complementary properly. Okay, so then if we're identifying complementary angles, we need to find angles that add up to 90 degrees. So in our diagram here, two angle measurements that add up to 90 degrees, let's look at 52 and then 38. So 52 plus 38 actually is 90 degrees, perfect. So then to identify the specific angles, we start from one end of the angle. So let's go with angle ABD, and so we started from this point ABD to identify this specific angle where the vertex is in the middle. And the complementary to that angle would be angle CDB. And notice how the vertex is in the middle of our label. So angle CDB. These two angles are complementary. Now for supplementary, a little trick that I like to use is I would draw a 180 using the S and the U, just like that. I mean, helps me at least. So then I need to find two angles that add up to 180 degrees, and I'll take the 52 and 128, add those up, see if they check out, and it does. So then I would write down angle ABC and angle B, let's see, oops, angle BDE. Perfect. And then finally, adjacent angles, we're looking for any angles that share a common vertex and they share a common ray. And here is an angle that not necessarily is straight, but they definitely do share a common ray right here and a common vertex at D. So a pair of adjacent angles would be, there's the angle I'm just highlighting here for you, angle CDB and angle BDE. Okay? Alright, in example 2, we have to find the measure of complements and supplements. So given that angle 1 is a complement, that has to be 90 degrees. So then the two angles that we're about to talk about have to add up to 90 degrees. The complement of angle 2, so given that angle 1 is a complement of angle 2 and measurement of angle 2 is 57, find the measurement of angle 1. So angle 2 is 57. We have to figure out what angle 1 is if we know that the two angles are complementary. So then angle 1 plus angle 2 has to equal 90 degrees, the measurements of each. So then knowing that the measurement of angle 2 is 57 degrees, substitute that in. So measurement of angle 1 plus 57 is equal to 90. Subtract 57 from both sides. That zeroes out. So then the measurement of angle 1 is equal to 33 degrees. So 33 degrees is the complement of angle 2. Alright, the final example, we have to identify angle pairs. Identify all linear pairs and all vertical angles in the figure. So linear pair, remember, we need to have adjacent and supplementary angles. So one thing that we do know is that on a straight line, the straight angle, its measurement is 180 degrees. Okay, so we want for a linear pair to be, the angles to be supplementary and adjacent as well. So let's look at this straight line. And right now I can see that this ray coming from it, it separates the two angles, or separates the straight angle into two angles, angle 1 and angle 2. And since I know that on a straight angle, this is equal to 180 degrees, so that just because there's two angles now formed, the sum has to equal 180. So we can say angle 1 and angle 2. And then we can also use the up and down straight line, and the ray coming out of that, angle 2 and angle 3 would also be considered a linear pair. Okay, they're right next to each other, they share a common ray, and they share a common vertex. Alright, so vertical angles, we need two straight lines that intersect, okay, all the way through, and the opposite angles that are formed, and we're looking for a pair, not a triplet, for it to be identifying our vertical angles. So then, if these are our two straight lines, the opposite angles, angle 1 and angle 3, are considered a vertical angle, or vertical angles. And that would be it. Let's go back to that diagram real quick because it just switched on us really quick. So again, the vertical angles, you have two straight lines that intersect. Angle 1 and angle 3 work, but notice how 2 and 4, 5 don't work because this opposite angle is split into two other angles. If this ray wasn't here, then 2 and whatever number that would be here would also be a pair of vertical angles. And officially, we can say that's all, folks. So make sure you do write down questions that you may have, and then we'll talk about it tomorrow. Have a good day.